In this video, I'm going to go through the answers to all of these exam questions. If you haven't actually done the exam questions yet, then please pause this video, do the questions, and then press play when you're ready to mark them. Okay, the first one I've just asked you to fill in a table again. I hope you've spotted, though, that I've switched the anode and the cathode around. So anode we know is positive, cathode we know is negative. So just pay attention to which way around it's put. The first one, lithium bromide, and it's in solution. So our rule was if it's in solution and the metal is not copper, then hydrogen will form at the cathode. So make sure you have hydrogen underneath the cathode. And then at the anode, it's just going to be bromine because bromine is a halogen and the halogen forms. Then I've got lithium bromide molten. So if it's molten, it just means you've melted it. There's no water present, so there's no hydrogen present. All you've got is lithium and bromine. Lithium is the metal. It forms at the cathode. Metal always goes to the cathode. And then bromine will form at the anode. The next one, calcium chloride in solution. Again, in solution is the same as aqueous. If the metal is not copper, then hydrogen will form at the cathode. And I'm going to have chlorine at the anode. Calcium chloride liquid this time, so there's no water present. That means calcium is going to form at the cathode and chlorine is going to form at the anode. The next one, copper iodide in solution. Again, in solution is the same as aqueous. This time the metal is copper. If the metal is copper, then copper will form at the cathode. And I've got iodine at the anode. Copper iodide liquid, okay, there's no water present. If it's just liquid, you've melted it. So copper is the metal, it's going to form at the cathode. Iodine will form at the anode. Magnesium sulfate aqueous. Aqueous, you've got water present. The metal is not copper, so hydrogen will form at the cathode. And then at the anode, when you've got sulfate, oxygen forms. Okay, so please pay attention to which way around I put anode and cathode. Right. The next one, we've seen a similar question to this. Which of the following is found uncombined? If it's uncombined, it means it's unreactive. And the only one of these that are unreactive is silver. So silver and gold are the ones you find unreactive. This we've seen lots of times already. You've got iron oxide and you've got carbon. Carbon is more reactive than iron. They will swap places and you will get carbon dioxide, but they will accept the mark for carbon oxide. And you've got iron. It doesn't matter which way around you write these products, and you'll get the mark for carbon oxide as well as carbon dioxide, but it's one mark for here, one mark for here. What happens to the carbon in this reaction? So if you look at the carbon going from left to right, carbon on the left has no oxygen, carbon on the right has oxygen. So carbon is gaining oxygen. So I'm just going to write that it's gaining oxygen. And the word to describe gaining oxygen is oxidized. The opposite to gaining oxygen is removing oxygen. So in the equation, iron oxide is losing oxygen going from the left to the right. So I would say iron oxide is reduced, and I would say carbon is gaining oxygen, so carbon is oxidized. The next one, you have to balance an equation, okay? So when I'm doing this, I look at how many iron atoms I have on the left-hand side, and there's a little number 2, which tells me I've got 2 irons. So I'm going to put a big 2 in front of the iron here, okay? Then I see I've got 3 oxygens on this side, but I've only got 1 oxygen there, so I need a big 3. And that means I've now got 3 magnesiums on this side, and I've only got 1 on the left. So I need a big 3 in front of magnesium. So we're always using big numbers when we're balancing. So this question, so it says lead carbonate, which is this here, decomposes to form lead oxide and carbon dioxide. It tells you that 534 tons of lead are decomposed. You get 446 of lead, calculate the mass. So if you're starting with 534 tons of lead carbonate, which that's what you're starting with on the left-hand side, all of that lead carbonate is being converted into either lead oxide or carbon dioxide. And they've told you that 446 tons is lead, which means the rest of it must have been converted into carbon dioxide. So it's a simple takeaway. 534 minus 446 is 88. So you started with 534. 446 got converted into lead oxide, 88 got converted into carbon dioxide, okay? But the point is that the overall mass is the same on each side. You're not destroying any of the atoms, you're just converting them into something else. So the masses have to balance on each side. So your answer there is 88 tons. This one, we've seen a similar question to this. Why is it more important to recycle copper than to recycle iron? Okay, so they've given you two columns in your table. One is about cost. You see that copper is far more expensive than iron. So I'm going to write copper more expensive than iron. And then you look at how much of it's in the Earth's crust, and you see you've only got 0.007% copper, but you've got 6.3 of iron. So I'm going to write copper. You can write rarer, or you can write less abundant or less common than iron. Okay. Next one, we saw something very similar to this in yesterday's set of questions. Okay. It tells you the chlorine is being formed here at the positive electrode. It just wants to know what this positive electrode is called. We remember panic. Positive is anode. So I'm going to write anode. State the name of the colourless gas formed at the negative electrode. So you've got the negative electrode here, which is your cathode. It's a solution. And I know in a solution, if the metal isn't copper, then hydrogen gas is going to form. So I'm going to write hydrogen there. Again, we saw this question yesterday. An alkali forms. How can you test? I'm going to use the same I used yesterday. Universal indicator turns blue, or you can write purple. But the name of any indicator and the colour it turns will get you the marks. Don't just write indicator and colour change. Name an indicator and tell me the colour change. You'll only get 1 mark if you just write indicator, colour change. Okay, we've seen this one as well. Why does solid not conduct electricity? In the solid, ions can't move. In the solution, ions can move and can carry current. So we've seen that one lots of times. Hopefully everyone's getting 3 marks there. The next one, this is a 6-mark question, so it seems a little bit intimidating. What exactly are you being asked? Just because it's a 6-mark question, please don't just leave it blank, okay? The answer is not difficult. Molten lead bromide can be electrolyzed. Describe how this experiment can be carried out in the lab, starting with solid lead bromide and explaining how the products of electrolysis are formed, okay? So you say you're starting with solid lead bromide, okay? So you're starting with a solid piece of lead bromide. And then they tell you that when you're doing the experiment, you have molten lead bromide. So if you want to go from a solid to a liquid, the first thing you're going to have to do is you're going to have to melt it. And once you melt it, you're going to get molten lead bromide. And once you've got it melted, then you're just describing what's going to form at the cathode, what's going to form at the anode. Okay, so if I were to draw a little diagram, and draw a diagram, if you know how to draw these diagrams, then draw it and you'll get lots of marks for it. Okay, so I've got my molten lead bromide in there. Okay, positive is the anode, negative is the cathode, and at the cathode, okay, the metal is going to form, so I'm going to get lead, and at the anode, the non-metal is going to form, and I'm going to get bromine forming at the anode. Okay, that diagram will pick you up quite a few marks. Okay, if you wanted to write it out in words, I'm just going to jot down a few bullet points. So I'm going to write, how do you melt something? You heat it. Heat lead bromide to melt it. Okay, that's going to be a first mark. Put your molten lead bromide in a beaker, which is what I've drawn, and insert the electrodes. Okay, I'm sure these things here, which again I've drawn, and insert electrodes. Connect electrodes to a battery. which is again what I've shown here in my diagram. Connect electrodes to battery, okay? Lead ions are positive. Metals are always positive. Lead ions are positive and will move to cathode. Okay, so lead forms at cathode. And I'm going to write bromide ions are negative and will move to anode. So bromine forms at the anode. And that will be all 6 marks, okay? And there's nothing in there that you don't already know. So don't be put off by a 6-mark question. Even just drawing out that little diagram is going to get you a lot of marks. The next part, which of the following is a formula from magnesite? I know we've never seen anything like this before. We've never seen this compound, but they're telling you the charge of magnesium is +2, and they're telling you CO3 is 2-. You need the charges to cancel. 2+ and 2- cancel, so you just need MgCO3. Because the charge is already cancelled, you just need 1 Mg and you need 1 CO3 and they'll cancel out. Which method are you going to use to extract magnesium? Okay, so they haven't drawn it in for you, but carbon would be here. Magnesium's more reactive than carbon, so you would have to use electrolysis. So you get 1 mark for mentioning electrolysis, then you get a mark for saying magnesium more reactive than carbon, and your final mark goes for you need a more powerful method than carbon. Okay, so because magnesium is more reactive, you need a more powerful method, you need electrolysis to extract it. And then here, last question. This goes back to the biological methods of extraction. So phytoextraction, that's the one where you use plants. An advantage is you can use, so they asked you to explain an advantage and a disadvantage. So it's 4 marks. So you get 1 mark for giving an advantage and explaining it, 1 mark for giving a disadvantage and explaining it. There's no point in giving 2 advantages. You just need 1 and you need to explain it. So my advantage would be low grade ores can be used, and I need to explain why that's the case, and I will say the reason that they can be used is because the copper becomes concentrated in the plant. And then a disadvantage, I'm going to say it's slow. That's a disadvantage. I need to explain why it's slow. And this one's a bit easier because plants take time to grow. Okay. You could also say a disadvantage is it's expensive, and the reason it's expensive is because you need to employ lots of people to grow the plants. So state an advantage, explain it. State a disadvantage, explain it. Just a reminder, phytoextraction, that's when you're using plants, you plant them and they absorb all of the metal into their roots. And once they've absorbed the metal into their roots, you can cut the plant down, you can burn the plant, and you can get the metal out of the plant. So again, any questions with any of those, just let me know.